Hi everyone, welcome to my YouTube channel Edu-spectra. In our previous class, we had discussed about our exercise number 1.3. So now let us move on to a new topic, which is operations on real numbers. Okay, so let's see here. So now we have learned about irrational numbers, and we said that all our imperfect roots are irrational number. Okay, so now we will be seeing a few properties of these irrational numbers, that is basically about imperfect squares. Okay, so another name for these imperfect squares is called as certs. Okay, so a cert means imperfect square, like your root 2, root 3, 2 root 3, etc. And you know, you have learned in your 8th, this root symbol is also called as the radical symbol. So now we will be learning some evaluation, some properties, okay, which involves these root symbols. Okay, so let us see one by one. So if you see the first thing, root 6 minus root 6. So we know, if we even do simply 6 minus 6, 2 minus 2, whatever we do, we will always get our answer as 0. So root 6 minus root 6 is equal to 0. No problem. Similarly, root 2 minus root 2, also we will get it as 0. Okay. Now just look at the other three one. Now if we are doing root 6 plus root 6. Okay. Now here the one thing that we might do is we will add the 6 and 6 and we will write the answer as root 12. Okay. It is wrong. Whenever we add two certs, always this root 6, whatever, always we should remember that when we are adding, the root, whatever inside the root is always same. If the quantity or the number which is given inside the root is not same, we can never add those two roots. So here if you see, here also we are having root 6, so here also we are having root 6. So when you write your answer, write that root 6 as it is. Then just see over here, outside this root we are having a 1 over here, and here also we are having a 1 over here. So we know 1 plus 1 is 2. So our answer will be 2 root 6. Okay, one more example I will give to you. If I say 2 root 3 plus 4 root 3. So how will you write the answer? Root 3, it will come as it is. Then you have to do 4 plus 2. So you will get your answer as 6 root 3. One more I will write root 3 plus 2 root 3 if I ask you. So root 3 will come as it is. 2 plus 1 it is 3. So we will get our answer as 3 root 3. Now if I ask you what is root 2 root no need. If I ask you what is 2 root 5 plus 3 root 2. Okay. Now you just see over here. Can we add these two certs? We can definitely not add these two certs. Why? Because here one we are having root 5 and here we are having root 2. The two roots are different. So if you ask what is the sum of this itself is the answer for that. Okay, we can never add. So just don't do like this, 5 plus 2 7, and just don't do 2 plus 3 5 root 7. Okay, don't add it like that. Always if the roots are same, okay, whatever inside the radical symbol is same, then only we can add those two numbers. Okay, similar is the case for subtraction. Okay, I hope I am clear. For example, if I write here 5 root 3 minus 4 root 3. So here root 3 is same, so root 3 will come as it is, and we know 5 minus 4 is 1. So we will get 1 root 3, or simply root 3 you can write. Okay, same is the case with subtraction also. Always you have to see whether the roots are same. Okay, now just see the next step, that is root 3 into root 3. If you are multiplying two similar roots, the root symbol will cancel off, and whatever inside that root will come as the answer to you. Okay, so if I say root 2 into root 2, what will be the answer? 2. Root 3 into root 3, the answer will be 3. Okay, so whenever there are two certs which are same multiplied with each other, we will get whatever is inside that cert. Okay, so similarly, if I ask you what is root 3 the whole square, what is root 3 the whole square meaning? Root 3 into root 3. And just now we told whenever two similar certs are being multiplied, we will always get the answer whatever is inside the root. Okay, so you should also remember this one. Okay, now the next one is root 3 divided by root 3. We know both of the numerator and denominator are same, so simply we can cancel it off and we will get our answer as 1. Okay, I hope till here I am clear. Points are very important for doing various problems which will come. Okay, okay, now just observe these two, root 20 and root 18. We know that root 20 and root 18 are imperfect roots. Okay, these are not perfect squares, but this root 20, we can actually do a particular simplification and write it in a modified form. Okay, this simplification is really important because in this chapter also, and when we do a Heron's formula chapter, it is also required over there. So just see how am I going to simplify this root 2 and write root 20 and write. Okay, so you know 20 we can write it as 2 into 10. Okay, am I right? Then this 10 I can further split and write it as 2 into 5. Okay, so 2 into 5 we know it is 10. 2 into 10 it is 20. I just simply splitted everything and wrote. Now we know that whenever we do square root, we should always take pairs of 2. So here if you see 2 are forming a pair. So I can group this as a pair, and whenever we get a pair like this, or otherwise you just see 2 into 2 is what? 4, right? So what is square root of 4? 2. Okay, so similarly if two similar numbers are forming pairs of 2, you can take that always outside, and what is left behind that? 5. So the simplified form of root 20 is 2 root 5. Okay, if you didn't get it, just see over here 2 into 10, I wrote 10 as 2 into 5. We know what is 2 into 2? 4. 4 into 5. We know what is square root of 4? We know square root of 4 is 2. That too I took it out, and what is left behind? 5. Okay, this is the way in which we do the simplification of a particular imperfect root. Okay, now just see the other example of root 18. Okay, if you see the example of root 18, how can we split and write root 18 as? We can write it as 2 into 8. Okay, then we can write it as 2 into 9. Then we can further write it as 2 into 3 into 3. 9 can be written as 3 into 3. Now just see over here, 3 is making the group of 2. Okay, so I can take 3 outside, and what will I get inside? Root 2. Otherwise also you know 3 into 3 is 9. Square root of 9 is what? 3. So that you can always take it out. So root 18 you can write it as 3 root 18. So this is the way in which we simplify a particular cert which is given to you. Okay. Now let us move on to our next concept, which is a very important concept which you require for your higher classes also, that is rationalization of denominator. Okay, now here one thing that you should always remember in the mind is that the denominator should never have root symbol. Okay, the denominator hates root. Okay, so whenever you see a root thing in the denominator, always try to remove that root too. So that is what we call it as rationalization. So the major concept of rationalization is that the denominator can never be root of something. Okay, so somehow we have to remove this root. Okay, so in such questions, how will you remove this root? Okay, so always in this method, whatever the root is given in your denominator, just multiply and divide it with this number. Okay, so here we are having 1 by root 2. The denominator is root 2. So that root 2 we are multiplying and dividing it. So when we do 1 into root 2 is simply root 2. Then as I said, root 2 into root 2, when we multiply two similar roots, that same thing will come over here. Whatever is inside the root, that will come over here. Okay, I hope I am clear. So now you just observe over here, the from a denominator the root sign went away. There is no problem if there is a root in the numerator, that is perfectly okay, but always the denominator should never have a root symbol. If there is a root symbol, we have to eliminate it. And what is the way in which we eliminate? We have to multiply the root of something which is present in the denominator and divide it also. Now one more question, just see over here, 1 by 2 root 3. What is the root thing which is present in the denominator? It is root 3. So multiply and divide the numerator and denominator with root 3. So 1 by 2 root 3 into root 3 into root 3. So I will get root 3 over here. Now just see, 2, just keep it as it is 2. Then you know what is root 3 into root 3? Root 3 into root 3 is simply 3. I told you, whenever we multiply two numbers, the root cancel off and whatever is inside it will come over here. So 2 into root 3 into root 3 means 2 into root 3 into root 3 is what? Simply 3. So we will get our answer as root 3 by 6. Okay? I hope I am clear. This is what we do in rationalization of denominator. Whenever we do rationalization of denominator, never in the denominator there should be a root thing. When if there is a root thing, we have to eliminate that root thing. So whenever we have to eliminate the third, just multiply and divide it with the root number or the third. So from our denominator, the root will be eliminated. So here we had a root 2. When we did our rationalization, we got a pure number over here without root. Similarly here also it was 1 by 2 root 3, we got 6 here. Okay, and the denominator is freed from this root. Okay, so this is the way in which we rationalize the denominators. Okay, now let us see a few more points over there. Okay, so if you are given a irrational number and you are adding it with a rational number, so a irrational number plus a rational number will always give you a irrational number. For example, let us see, root 2 plus 3. Okay, we will always get the answer as a irrational number. Okay, why? Because root 2 we know it has a non-terminating, non-recurring decimal expansion. If we are adding it with 3 also, the expansion will be a non-terminating, non-recurring. So definitely root 2 plus 3 will be a irrational number itself. Similarly, if you are doing an irrational number minus a rational number, you will get an irrational number itself. Okay, like root 2 minus 3. Here also, if you are doing a rational number into a rational number, for example, 2 into root 3, so we will get 2 root 3 as the answer. That also is an irrational number. If you are doing irrational number by a rational number also, we will get our answer as irrational number. That is root 2 by 3. This is also an irrational number. Now, if we are adding a irrational number plus a rational number, or irrational number minus irrational, irrational into irrational, or irrational divided by irrational, the answer can be a rational number or irrational number. It depends upon question to question. Okay, so these are a few points that you should keep in your mind because we may require them in our questions. Okay. Okay. So now let us see a few more properties over there, or what we can call it as identities. So if you see the first identity, root of a into root of b is equal to root of ab. For example, if I say root 2 into root 3, this we can write it as root of 2 into 3. 2 3s are, we know, root 6. Okay, this is the first identity they are saying. Okay, both of them are different, we can always multiply it, right? So but if it is root 2 into root 2, if both of them are same, okay, just don't okay, when if you multiply also you will get root 4, and you know root 4 is what? 2. Okay, instead of doing all these steps and all, if it is two similar numbers that we are multiplying, just write whatever you are getting, whatever is inside this root as the answer. Okay, I hope I am clear. This is the first identity. Okay, then the second identity is root a divided by root of b is equal to whole root of a by b. For example, if I say root 2 divided by root 3, we can write it as the whole root of 2 by 3. Okay, this is your second identity. Okay, now the next set of identities are very similar to you because you have learned it in your class 8. Okay, so we know a plus b the whole square. We know how to expand a plus b the whole square identity, which we have learned in a class 8. So what is a plus b the whole square? A square plus b square plus 2ab. Similarly, if I ask you a minus b the whole square, how can I expand it? A square plus b square minus 2ab. Okay, that is the difference. Here you have plus 2ab, here you are having minus of 2ab. So now the next one is a very important identity, because this is one which we or most of the time use in a higher classes very much. Okay, that is a plus b into c plus b's expansion. Okay, I call this expansion as the dancing queen method of expanding it. Okay, so let's see how are we going to do this dancing queen. Okay, first of all, just fix this one. Okay, we are fixing this one and we have to multiply this a with this c. Then we have to multiply this a with this b. Okay, like we are just dancing and going. So multiply a with c, then a with b. Then after that, fix this b. Okay, then again we have to do our dancing queen. So b goes to c, that is b into c plus b into b. Okay, that is the way in which we have to do our expansion. We have to multiply, that is a into c plus a into b plus b into c plus b into d. Okay, like just we are doing dancing. First of all, fix a. After fixing a into c we should do, then a into d. Then after that, fix b. Okay, here a and a is fixed. Here b and b is fixed. After fixing b, do b into c and b into b. Okay, this is the way in which we have to do our expansion. Okay, I hope I am clear. Now this sixth identity also is really familiar to you. That is a plus b into a minus b. We know a plus b into a minus b is equal to a square minus b square. Okay, these are your six identities which you should keep in mind while we are doing our question. Okay, so now let us see our example number 14, that is 6 root 5 into 2 root 5. Okay, so we have to multiply these two certs given to you. Okay, so what do you have to do over here? First of all, take all the things which is present outside the root together. So I will do 6 into 2 as one thing. Then what is that? Root 5 into root 5. So I will write that also. Root 5 into root 5. So we know 6 into 2 is 12. And I have told you root 5 into root 5. Whenever two similar things are multiplied, just write that whatever is given inside the root itself. So we got 12 into 5. So your answer will be 16. Okay, I hope I am clear. So once again I will tell you, first of all we took the things which is present outside the root together. We multiplied it with whatever is in the roots. So 6 into 2 we got it as 12. Root 5 into root 5 we got it as 5. So 12 5s are 16. This is your answer. Okay, so now let us move on to our next question, which is example number 15. Okay, this is a very important question that you should know. Okay, so here also we have to divide 8 root 15 by 2 root 3. So I have told you, in the denominator does not like any certs to be there in its denominator. So we should always eliminate this root 3 in some or the other way. So let's see, how will we do? Just multiply and divide the numerator and denominator with this root 3 to eliminate it. So 8 root 15 divided by 2 root 3 into root 3 divided by root 3 you should do. So just see over here, we know that this 8 you can write it as it is. 15 3s are, we know it is 45. So we will get 8 root 45 in the numerator. We know that this here we are using our first property, that is root a into root b is equal to root of a into b. So that is, we can always do this as 8 we took it here, then we did 3 into 15 which is 45 divided by, okay, 2 into 1 it is 2 itself. Root 3 into root 3 it is simply a 3. Okay, I hope I am clear. Now next we can do a manipulation inside this root 45. We can simplify this root 45 and write. Just see how am I simplifying it. 8. We know that 45 we can write it as 5 into 9, isn't it? Divided by 2 3s are 6. We can write. Similarly, 9 we can again simplify and write it as 3 into 3. 9 I am writing it as 3 into 3. Okay, so you see here 2. This 3 is present as a group of 2. So otherwise we know 9 into 9 it is 3 itself. So we can take this 3 outside the root. So what will we get over here? 8 into this 3 comes out root 5. Okay, if something is present as a group of 2, take it always as outside. Take it always outside. Okay, so here we got 8 into 3 by 6. So what are 8? 8 3s are 8 3s are, we know it is 24 root 5 divided by 6. We can cancel it off. We know 6 4s are 24. So we will get our final answer as 4 root 5. Okay, I hope I am clear. This is your final answer. 4 as 4 root 5. Okay, I hope I am clear. Here basically we are using the concept of rationalization over here. Then identity root A into root B identity, and finally a simplification of a third. Okay, we simplified this root 45 and wrote it as 3 root 5. Okay, so this is a very nice and an important question which can be asked for your exam. Okay. Okay, so now let us move on to our example number 16. The question is, simplify the following expression. Okay, we are giving 4 expressions. We have to simplify each one of them. The first question is 5 plus root 7 into 2 plus root 5. Okay, so here basically if you see this question, the identity that should come to your mind is A plus B into C plus D identity. Okay, so we have to use this identity and simplify. Okay, and this identity I call it as the dancing queen identity, because we are just dancing and going like that. Okay, so let's see how will we do it. Okay, I have told you our first step is what? Fix this 5 over here. Just do the dancing step. So 5 into 2 we have to do, plus then what do we have to do? This 5 into this root 5. So 5 into root 5 plus, then we have to fix this 7 and multiply it with 2. So you will get 2 into root 7 plus, then fix this 7 and multiply it with this 5. So I will get it as root 7 into root 5. Okay, so now it is very easy for us to simplify this thing. So we here 5 into 2 we will get it as 10 plus 5 into root 5 which is 5 root 5 plus 2 into root 7 it is 2 root 7 plus root of A into root of B is equal to root of A into B. So we can write this as root of 35. Okay, so this is your final answer. Okay, now our second question is 5 plus root 5 into 5 minus root 5. So let us root 5. So let us see 5 plus root 5 into 5 minus root 5. The identity that should come to your mind is A plus B into A minus B. We know A plus B into A minus B is equal to A square minus B square. So here we can take this 5 as A and root 5 and we can take root 5 as B. Okay, so we know we should do A square minus B square. So here A is 5. So I am doing 5 square minus, what is B over here? Root 5. So I am doing root 5 the whole square. We know what is 5 square? 5 square it is 25. Root 5 the whole square means root 5 into root 5 which is equal to a 5 itself. Okay, root 5 the whole square means root 5 into root 5 which is 5 itself. So we know 25 minus 5, what is the answer that we are getting? 20. Okay, so I hope I am clear. Okay, here we should use this identity and solve a question. Always just see if the question given to you is it in the form of any identity. We always know the expansion of them. Just apply the expansion and find your answer. Okay, I hope I am clear. Let us move on to our next question, third one. Just root 3 plus root 7 the whole square. So you see here, this is which identity? A plus B the whole square. We know A plus B the whole square is A square plus B square plus 2AB. So this is of that form. So we can just expand it and see. So root 3 I can write root 3 the whole square plus b, it is root 7. So I will write root 7 the whole square plus 2 into, this is your a, this is your b. So 2 into root 3 into root 7. Okay, this is root 3. So we know root 3 the whole square means root 3 into root 3. Root 3 into root 3 is simply 3 plus root 7 the whole square means root 7 into root 7, which is simply 7, plus we know 2 into root of a into root of b is equal to root of a into b. So we know 3 plus 7, it is what, 10, plus 2, 3 7s are 21. So you will get your answer as 10 plus 2 root 21. I hope I am clear. Okay, let us move on to the fourth one, which is root 11 minus root 7 into root 11 plus root 7. Okay, so here also if you see, we have to use the a plus b into a minus b identity. We know a plus b into a minus b is equal to a square minus b square identity. So here a plus b into a minus b. Take this as a, take this as b. So a square, that is root 11 the whole square minus root 7 the whole square. Root of 11 means root 11 into root 11, which is simply 11, minus root 7 the whole square means root 7 into root 7, which is simply a 7. 11 minus 7, it is equal to 4. Okay, this is your answer. Okay, so now let us move on to our example number 12. The question says, check whether the following are irrational numbers or not. Okay, so they are asking you to check whether the given numbers to you are irrational or not. So the first one is 7 root 5. So we know, I told you, whenever we are doing a rational into an irrational, always the answer will be an irrational number. Otherwise also you think, we know root 5 has a non-terminating, non-repeating decimal expansion. If we even are multiplying it with the 7, definitely it will always have a non-terminating, non-recurring decimal expansion. So this is definitely a irrational number. Okay, now just see, this is irrational number. Now just see the next question, 7 by root 5. I told you, whenever there is root 5 or a root number or surd in the denominator, always eliminate it. So I am having 7 by root 5. I have to multiply it with this root 5 itself to get rid of it. So I will be getting 7 root 5. Root 5 into root 5 is what? A 5 itself. Similar roots, when we multiply whatever is inside the root, just write as it is. Now just see over here, this is irrational by rational. I told you, irrational by rational is always irrational itself. Otherwise also we know 7 into root 5 is what? Non-terminating, repeating, non-terminating, non-repeating divided by something is always non-terminating, non-repeating. So this also is what? Irrational. Okay. Now just see the next one, root 2 plus 21. We know root 2 is what? Non-terminating, non-repeating. This is a irrational plus a rational. Again what? This is a irrational number. Now the last one is pi. Pi we know 3.14. Non-terminating, non-repeating. It is a irrational number minus a rational number. Again what? It is a irrational number. So all the things which, all the quantities which are given to you in the example number 12 are irrational numbers. Okay, I hope I am clear. Okay, so let us move on to our next question, which is example number 13. The question is 2 root 2 plus 5 root 3. We have to add it with root 2 minus 3 root 3. Okay, so let's see how will we do the addition. Now just see over here. Here we are having this plus this. Just see. This root 2 and this root 3. I told you, if only the roots are similar, we can add always. So here also just see root 2 and root 3. The roots are not same. So here also we cannot subtract. Okay. So basically whenever we have to add or subtract something, always bring the common things or the common certs together. Then only we can add or subtract. Okay, so here you see one root 2 is here and another root 2 is here. So group them together. So I can write 2 root 2 plus root 2. Okay, I am grouping the root 2's together. Then plus I will take this root 3 and this root 3 and group it together. So I will get 5 root 3 minus 3 root 3. Okay. Now as I told you, whenever roots are similar, you can always add or subtract. So how will you do? Whenever this thing, this common thing, just write this as it is. Root 2 is common, then here you are having outside the root 2, here outside the root you are having 1, 2 plus 1 it is 3, so you will get 3 root 2 plus here also root 3 is still common, so write root 3 over here, then do 5 minus 3. What is 5 minus 3? 2. Okay. Now see, now this is the answer that you have got, 3 root 2 plus 2 root 3. You cannot do anything further with this because here we are having root 2, here we are having root 3. Okay, so if the roots are not similar, we simply cannot add both of these things. So this you can write it as your final answer. That is 3 root 2 plus 2 root 3. This is your answer. So example number 30. Okay, so now let us move on to our example number 17. This is again a very simple question. The question is, rationalize the denominator of 1 by root 2. So as I told you, whenever there is root 2 in the denominator, there should never be a third in the denominator. So somehow we have to eliminate this root 2. So what you should do, multiply and divide it with this root number. So we can do 1 by root 2 into root 2 divided by root 2. So we will get root 2. Root 2 into root 2, it is a 2. So we got a final answer as root 2 divided by 2. I hope I am clear. Okay, so now let us move on to example number 18. Example number 18 is a very important type of questions which is usually asked for your exams. So the question is, rationalize the denominator of 1 by 2 plus root 3. Okay, now here also if you see, there is a root number which is present in the denominator, but it is a little complicated root which is given to you. So whenever in the denominator there is something like 2 plus root 3, 2 minus root 3, etc. So here just don't multiply both the numerator and denominator with root 3. Okay, that will be wrong. Because here the question is 2 plus root 3. There is a plus sign in between. Okay, so if in the denominator there is a plus minus sign, always we have to take the conjugate. Okay, that is the word. Conjugate. Okay, whenever there is a plus or minus in the denominator, always take the conjugate. Now what do you mean by conjugate? Conjugate means that if I say 2 plus root 3, the conjugate of 2 plus root 3 is 2 minus root 3. We are just changing the symbol which is present in the center. That is the meaning of conjugate. For example, if I ask you the conjugate of 2 minus root 3, what will be? It will be 2 plus root 3. If I ask you the conjugate of 3 minus 2, so what will be the conjugate of 3 minus 2? 3 plus 2. Okay, this is the meaning of conjugate. Okay, so now whenever there is a plus sign along with the root, we have to always take the conjugate and multiply and divide this conjugate with this number. So here I am having 1 by 1 plus root 3. So what is the conjugate of this 2 plus root 3? 2 minus root 3. That you have to multiply and divide. Okay, so this is the thing that you should do over here. So we know 1 into 2 minus root 3 is 2 minus root 3 itself divided by, here you see this of the form a plus b into a minus b. We know a plus b into a minus b is what? A square minus b square. In the denominator we have to use an identity. So a square means 2 square minus root 3 the whole square. So here I will get 2 minus root 3 divided by 2 square means 4 minus root 3 the whole square means 3. 4 minus 3 we know just 1. So our final answer will be 2 minus root 3. Okay, I hope I am clear. This is a very important question that is asked for your exam. Here example number 19 is, rationalize the denominator of 5 by root 3 minus root 5. So just see over here, just like a previous question, here there is a minus or a plus sign in the denominator. Here we are having a minus sign. So what should we do? We have to multiply and divide it with the conjugate. So the conjugate here is root 3 plus root 5. The conjugate of root 3 minus root 5 is root 3 plus root 5. So I can write 5 by root 3 minus root 5. I am multiplying and dividing it with the conjugate. So minus will become plus over here. Okay, so the whole divided by root 3 plus root 5. So 5 into this we can, how can we write? I will take 5, put a bracket over here, root 3 plus root 5. I can write the whole divided by the denominator. This is of the identity a plus b into a minus b. We know it is a square minus b square. So here we can just open it up and write 5 root 3 plus 5 root 5 the whole divided by root 3 the whole square is 3 minus root 5 the whole square is 5. So if you see here 3 minus 5 is minus 2. So you will get 5 root 3 plus 5 root 5 divided by minus 2. So we should never keep the minus sign in the denominator. So just take it into the numerator and write it. Okay. Now if you want, you can simplify and write it. If you see this 5 root 3 by 2 is common, this root 2 is common to this and this also. So we can take this minus 5 by 2 outside the bracket like this. Okay, then what is inside it? Root 3 plus root 5. Okay, you can also simplify and write the answer like this. Okay, just what did we do? We took this 2 outside and just put a bracket. So when we open the bracket, we will get back the same thing. That is minus 5 root 3 by 2 plus minus 5 root 5 by 2. The same thing we will be getting over here. Okay, this is a much simplified form of a answer. Okay, so I hope I am clear. So now let us move on to our last question in our exercise, which is 1 by 7 plus 3 root 2. So here also we have to take the conjugate and multiply. Here the conjugate is what? 7 minus 3 root 2. So I will write 1 by 7 plus 3 root 2 into plus becomes minus. So 7 minus 3 root 2 divided by 7 minus 3 root 2. So we know in the numerator we will get 7 minus 3 root 2 itself divided by the denominator. Again we have got our identity a plus b into a minus b, which is a square minus 3 root 2 the whole square. So here we will get 7 minus 3 root 2 itself divided by 7 square, we know it is 49 minus what is 3 square? 9 into root 2 the whole square. Okay, always we have to start from left. We have to go one by one. 3 square we wrote it as 9. Root 2 the whole square, it is root 2 into root 2. So it will be simply be a 2. So from here we will get 7 minus 3 root 2 divided by 49 minus 2 nines are, we know it is 18. Okay, so 49 minus 18 is okay, so 49 minus 18 is what? 70. Okay, so here we will get 7 minus 3 root 2 divided by 49 minus 18 is 31. Okay, so this is your final answer. So in this examples, whenever this type of questions are very important, where we multiply and divide with the conjugate. Okay, if there is a plus or a minus in the denominator, always multiply and divide it with the conjugate. Okay, so we have completed all our examples. I hope everything that we discussed is clear. Okay, so now we will meet in our next video with our next exercise. Till then, thank you. Please like, share and subscribe the channel.